Hi there. Okay, today I thought to do very interesting problem. So I'm not going to write down the questions here. So I will just simply draw the diagram. From the diagram you will understand. I hope you will understand the problem. I'll just simply summarize the problem. Okay, the problem is like this. You have a cart and this is kept in a frictionless surface. And his mass is negligible. Okay, there is a person, big game, his mass is big game, and he's holding 100 marbles. Okay, so each marble has a mass of small m. Now he's throwing all the marbles at once in the horizontal direction with a velocity v, small v. Initially the system is at rest, so this is at rest initially. The question is, if he throws all the marbles at once in the same direction, what is his recoil speed? So the question is, okay, so this is initially. Finally, what's happening? He is throwing all the marbles, all the 100 m with a small velocity v. So this is actually, this velocity I forgot to tell. Okay, so this is with respect to Earth. Okay, so he's throwing all the marbles at once in the same direction with this velocity small v. The question is, okay, what is his recoil velocity? So the problem is super simple. Why? Because you can simply use conservation of momentum. So initial momentum is 0. I said this was at rest. The final momentum is 100 m moving with a small v velocity, minus sign. Why minus? Because this system is moving, I'll say, okay, with respect to Earth is moving with a velocity u. So the big game is moving in the opposite direction, so I have to put minus sign here. So if you simplify, you will get 100, this is 100 mv by big game. Well, so this question is very straightforward question. No more complication. If you can just apply the formula, conservation of momentum, you'll get the answer. Okay, the next part of the problem, that's quite interesting. So now he's throwing all the balls, not all the balls at once. Now he's throwing one ball at a time, and he's throwing all the 100 marbles. Okay, so he's throwing one at a time, but now this velocity is not with respect to Earth. Now this is with respect to the cart. Okay, so he's throwing the ball one at a time with respect to the cart. So what would be his final recoil velocity? That is the question. So this question is not a really straightforward question, but it's not very complicated either. So okay, now he's throwing one at a time. Okay, so remember this velocity I told you, this is with respect to the cart. So you need to find what is this velocity with respect to Earth. So let me say this, when he throws this, so this cart is moving with a velocity u, right? This velocity is with respect to Earth. So what would be the velocity of this marble with respect to the Earth? So how do you find it? Let me denote this marble by C and this frame by S. Okay, and I will use Okay, here is an Earth observer. Earth observer is E. So now I know the velocity of this marble with respect to our S frame is V. This way, okay? And the velocity of this cart, this S frame, okay, so that is given, or it's not given, we are taking this as U, but it's moving in the opposite direction. So what is the velocity of this marble with respect to Earth? You can find CS plus VSE. What is CS? CS is V plus SE is in the opposite direction U. So with respect to Earth, this marble actually moving with V minus U speed. Okay, this way. Because remember, when you apply the conservation of momentum, you have to put all the velocity should be in the same frame of reference. So if you say this is in Earth frame, you can't put this velocity. So you need to convert all the velocity in the same frame of reference. So that's why I found this velocity of the marble with respect to the Earth. Okay, so now let's apply the conservation of momentum. So what is initial momentum? It was 0 because the system was at rest. The final momentum, this small m, is moving with V minus U speed, minus sign. Why minus sign? Because this cart is moving in the opposite direction. So minus big M plus, now there are only 99 marbles. Okay, it is moving with velocity U. Now you can simplify this. So if you simplify this, what would be the answer? So this is 0 mv minus, okay, here you are getting minus 99. Okay, so you will get U equal to minus, so this is mv divided by big M plus 100 M. So this is the velocity of the cart in the negative x direction when he throws the first marble. Now remember this, okay, mv by m plus 100 m. Now he is throwing the second marble. He's going to throw the second marble now. So I'll erase everything because I don't have a lot of space here. So now, so the person is here, his mass is big M. Now he's holding what? 99 small m, and this cart is moving initially with the velocity U. And you know this velocity, okay? Just now we obtained this U we obtained, we said mv by big M plus 100 small m. Well, so now he is throwing the second marble. When he throws the second marble, so let's assume again he is throwing with the same speed, okay? Same speed v with respect to the cart. So this is small m. So the big M now, this is big M plus this become 98 small m, and let's assume the recoil speed of the cart is now U prime. Well, right, now you see again he is throwing the marble with velocity v with respect to the cart. So this cart is moving with respect to Earth with this U prime speed. Now again we can apply the same method I used before to find what would be the velocity of this small m with respect to the Earth, and that is very simple. that velocity would be what? V minus u prime. Remember this. Okay, so but now this time, what is the initial momentum of the system? The initial momentum, this is already now in motion. Okay, so minus, this is the initial momentum, m plus 99 small m. It's moving with velocity u. I put a minus sign. Why? Because this is actually moving in the opposite direction, which is equal to the final momentum. This small mass is moving with this speed now. Remember, I can't put this v because this v is with respect to the car. I have to put the velocity with respect to the earth. So with respect to earth, this is v minus u prime. So I can say this is v minus u prime. So when he throws this one, he is recoiling with u prime speed. So what is that u prime? That is in the opposite direction. So I'll put a minus sign, right? Now what is the total mass of the system? Big M plus 98 small m u prime. Okay, so look at this. So let's simplify this. Here minus mu prime minus 98 mu prime. So I'll get mv minus, if I take u prime as a common factor, I'll get big M plus 99m. Remember, this is 98 plus 1 is 99m. So from here I can find the new velocity u prime is equal to mv, right? mv, yes, yeah, mv plus big M plus 99 small m u divided by this factor, okay, big M plus 99 small m. So from here now I can say the u prime is mv by m plus 99 small m plus u. Okay, now what is u? U is here. This is our u. So instead of writing u, I will write down mv over m plus 100 m. So this is the velocity of the cart when he throws the second marble. Now, okay, from here you can see the pattern. What would be his recoil speed when he throws the third marble? Okay, I don't want to waste the time. I hope you can do the problem. You can simply say, okay, the third time he'll be having m plus 98. It is u m, yeah, 98m, which is already moving with this velocity. So apply the conservation of momentum. He is throwing with m. So say u double prime this time. So this become m plus 97m. You can find u double prime. So when you do this, you will obtain u double prime would be, okay, trust me, you will obtain this answer, mv by m plus 98m plus mv by m plus 99m plus mv by m plus 100m. So you will obtain this answer. Okay, so from here you can guess, if you throw all the 100 marbles, what would be its speed. So I'll say, okay, u100. From this pattern you can immediately come to that conclusion. Okay, so the speed would be mv by m plus small m plus mv by m plus 2m plus ... you see you'll get all these factors, right? mv by big M plus 99M plus mv by big M plus 100M. So this is the speed after throw all the marbles one at a time. So I can write down, okay, instead of writing all things, I'll erase this. Now he can write down now this is actually summation of, let's say, I is equal to 1 to 100. I can write down mv by big M plus I small m. So this would be his final speed. Okay, now let's assume, okay, let's say small v is 5 meter per second. Okay, so he's throwing the marble 5 meter per second, one at a time. Okay, so I'm going to just give the value, the numerical values, and the big mass is 60 kilogram and small m, I'll say, okay, 0.1 kilogram. So the question is, what is his final speed, final recoil speed? So you can use your calculator, or you can actually there are some online sites where you can just substitute these values to find the summation. Okay, so if you find it, you'll obtain u100 is very close to 0.77 meter second minus 1. So if he throws marble one at a time, he will obtain this speed. And what about the previous? Because the previously I said he's throwing all the 100 marbles at once. In that case, what would be his velocity? Okay, so you remember, I hope you remember. So the initial, it was, his mass was m, and he has all 100 m's, and he was actually throwing all the 100 m's at once. So in this case, what would be his velocity? We calculated so this big M is moving with u. So we said initially the momentum is 0. The final is 100 m is moving with v minus big M is moving with u. So we said u is equal to 100 mv by big M. So in this case, what is the answer? 100 times 0.1 times 5 divided by big M. What is big M? I told you 60.